Hello, and thanks for joining us today, and welcome to Session 1 of Innovator Island, where we'll be building a serverless web application for a theme park. My name is James Bezic, and I'm a serverless developer advocate. Before I was a DA, I was a product manager for a long time, and also a software developer for many years. I'm a serverless geek, so I've built many different serverless applications using only serverless services. The most important thing on this slide is my email address and my Twitter handle, so if you have any questions about the workshop or in serverless in general, please feel free to reach out to me and I'll do my very best to help. So in the agenda today is 3 different things, and the goal is to really help you learn a range of different AWS services that you can use to build a real-time web application. All of the code is provided for you, so you won't need to write any actual code to solve the challenges. This is a virtual workshop environment, so there's 5 videos and they're consecutive. Each one follows on from the last. We'll be talking about using serverless services. The workshop is designed to cover a wide range of different serverless services. So the goal is to use these services in a real application so you can see how you might be able to use them in your own apps. I'm going to walk through the workshop and do the exercises with you side by side. As we progress through the workshop, I'll stop regularly to deep dive into common questions about each topic. I'll also answer common questions that I hear from the audience periodically. The full agenda for the whole series is posted at this link at the bottom of the screen, s12d.com/island workshop. There are some prerequisites for you to be able to do this workshop. The first is you will need an AWS account. If you don't have one, you can sign up at aws.amazon.com. Also, let's talk about cost, because this workshop is completely free, but running the steps might incur small charges. For most people, it should be doable within the free tier. To take part in the workshop, you'll need a laptop or a desktop computer, not a tablet. And please use the Chrome or Firefox browsers for optimal compatibility. We'll be building the serverless application with a wide range of different services like Lambda, API Gateway, DynamoDB, just to name a few. Existing familiarity with the management console in AWS is helpful, but it's not required. Our goal in this whole series is to help you complete the workshop and learn about these services. So let's talk about each of these services briefly and how it's going to be used. There are 3 key developer tools. AWS Amplify Console helps us automate publishing our front-end application. It makes it easier to implement a simple CI/CD pipeline. Code Commit is a Git-compatible repo for us to store our code. We'll be coding using Cloud9 IDE, which we'll talk about more in just a second. On the back end, we'll use Lambda. This is an on-demand compute service. Now, serverless includes a broad range of other services too, some of which we'll be using here. Innovator Island is a front-end and a back-end application, and API Gateway is the front door to that back-end. S3 is a highly durable object store. So in this app, we use it for storing binaries like user photos. QuickSight is for business intelligence. You'll see this later, how we can use this to see how the park is performing. EventBridge is one of the newer serverless services. It's a serverless event bus, and it makes it easier to decouple parts of the backend to help keep our services simple. It also makes it easier to add new functionality down the road. DynamoDB is a low latency, high throughput NoSQL database. It's the database behind the Innovator Island application. SNS is a flexible, low-latency messaging bus. This makes it easy to pass messages between different services, but also send emails or SMS text messages. Since many modern web applications use real-time integration, we'll be achieving this using IoT Core, and we'll be discussing how this works in detail in the next session. And then finally, you'll be using Kinesis Data Firehose. Our park guests wear wristbands which tell us which rides they're visiting. So Kinesis lets us ingest this large amount of data and then process it using tools like QuickSight. So although this is quite a few different services, we'll cover each one in more detail as they come up. So why are we using Cloud9? Well, the workshop's been tested with Cloud9, and that helps us to avoid any issues with laptop builds or local configurations. Also, please use Chrome or Firefox when you're opening Cloud9 for optimal compatibility. Cloud9 is a fully featured cloud-based IDE. It has integrated tools for serverless development, but it also has a built-in terminal so we can run terminal commands, and it has temp space for us downloading files and building the workshop. Cloud9 works with provisioned bandwidth within the AWS network, so when you're downloading large files, it's no longer dependent on your local Wi-Fi. And the workshop is 100% browser-based, so please don't use your local IDE or terminal. So welcome to Innovator Island. So the background to this workshop that it was built for AWS reInvent. In 2019, we ran 3 workshops with about 500 people. And since then, I've expanded the workshop with new modules for other events such as Serverless Days Nashville. Since reInvent, another 5,000 people have gone through the workshop. It's also used internally at Amazon to help Amazon learn about how to use serverless services. It's designed to showcase SPA-style apps. SPA is a single-page application frameworks. And so we show how you can use a serverless backend for applications that have large numbers of users. The scenario for Innovator Island is that the theme park is opening at the end of the week, and this app provides navigation for the 50,000 daily park guests who are expected to arrive, and they're going to be using their smartphones to navigate around the park. So, in the first step, we'll be deploying the front-end application. This application has already been built. Once you deploy this, you can access the application from both your desktop, browser, and your smartphone. And in the next sessions, we'll be adding functionality to the application. So to do this, we'll be using the AWS Amplify Console to connect the front-end code repo. This implements a CI/CD process automatically, and that means anytime that you commit changes to the repo, it automatically republishes the front end to a public URL. You'll also deploy many of the backend services that you'll need for the following modules. To do this, we're using the Serverless Application Model, SAM, to deploy these resources. Sam the squirrel is also the park's mascot, so you might see him around the application when you're testing things. SAM templates make light work of deploying serverless infrastructure, and you'll be finding out about this a bit more later. All of this we'll be doing with the Cloud9 IDE. Okay, so let's get started. So to start with, you'll want to go to s12d.com/island workshop, and that's where we'll be pulling up the instructions to better follow through. So today we'll be covering getting Cloud9 started and running and deploying the front end and the back end applications. At the moment, the front end doesn't do very much, but in the next few videos we'll start adding core functionality to make it more useful to park visitors. After doing this video today, please don't terminate any of the resources you created, since we'll continue to use these in subsequent videos. If you close the Cloud9 browser, don't worry, it suspends anyway after 30 minutes. When you open Cloud9 again, all of your resources will be sat there waiting for you to continue. To get started, I'm going to go to that URL that was on the screen before, s12d.com/island workshop. That'll take us to this instruction page that contains everything we'll be using over the next 5 videos. So let's start looking at this. So first of all, this gives us the preamble about how the workshop works, and also if you're attending this at an event, what you would do to follow those instructions. So in the introduction, we talk about the scenario and the application structure overall, and the expected cost if you're running this in your own account. So I'll click through. So Innovator Island is a theme park where 50,000 people a day will be expected to attend, and we're building the app they will use to navigate park rides. So the scenario is that we have parts of the code and we're going to be putting it together to be able to build the application. So you won't actually need to be coding any JavaScript today, but you just need to be able to follow the instructions in this workshop to be able to assemble the application and build the back-end serverless resources. So the application structure contains a front end and a back end. This uses a single page application framework called Vue.js. And so with that, we'll be building a front-end application and distributing it using AWS to a large number of users. So I'll be walking you through how that works. On the back end, that architecture uses services like Lambda, API Gateway, Amazon S3 and DynamoDB and Cognito. So there's quite a few different services involved with this workshop. But the key thing to understand is that JavaScript that's executed on the front-end browser sends and receives messages to the backend. And so there's really two applications involved here. Now this page here shows a diagram of what we're going to be building, which looks fairly complicated, but we're going to be building it piece by piece. You'll see how this is put together. So in the first step today, we're going to be deploying this application. That's what we'll be doing in the first session of this video series. And when we're finished, the architecture will look like this. So this is a useful page to bookmark and keep in mind as we start to develop things. Now in the Modules tab, you'll see an introduction to the different modules that are involved. We frequently update and change this workshop, so you may see new modules appearing after this video is recorded. Once we've gone through all of the different videos, it's also important to make sure that you look at what's in the cleanup section, because you don't want to leave these resources running and incurring any cost accidentally. So make sure you have a look at cleanup once you are finished following this series. Now in terms of cost, if you're following this video series at an AWS event, the account will be provided for you, so this is not something you need to worry about. But in terms of deploying resources into your AWS account, you should be aware that you may incur some cost in doing so. Fortunately, most serverless services are very inexpensive to run, especially in this sort of test phase that we're running today, but it's possible to incur some costs, so do be aware of that. To make sure you don't incur any ongoing costs, make sure you look at the cleanup section of this workshop when you're finished. So in this setup phase, we're going to be looking at how you set up the different parts of what we need for the workshop. Also, we'll talk about different regions you can use for deploying resources and how we're going to be using Cloud9 IDE to get this all working. So to do this workshop, you'll need an AWS account. If you don't have one, you can go to aws.amazon.com, and from there you would hit create an AWS account. If you need to do this, just pause this video here and I'll be waiting for you when you come back. Otherwise, if you have an account, what we'll be doing next is signing in. So to sign into your account, just go to aws.amazon.com and follow the sign-in steps, and I'll see you in just a few seconds. I'm going to sign into my console, so this is what your console should look like too. Now what I'll do to make this easier is I'm going to split my screen so that the console is on the right and my instructions are on the left, so you can see at all times what I'm doing in both. So the important thing is this workshop assumes that you're using an AWS account where you are the administrator and there are no other users in the account. So typically it's ideally suited to a personal account that you haven't generally been using for lots of things. That way we can make sure that everything deploys as expected. You can always create a new AWS account to do this, remember, so just follow the link to do that there. Now this workshop only supports the regions shown in this list. This is a list that may change, so make sure that you're looking at the latest region list that's available in the link that you're looking at now, not the one recorded on this video. But right now we have 6 different regions that you can use for the workshop. So make sure that you're in one of those regions. The way you do that is when you're in the console, in the top right hand corner, you'll see the region drop down. And this lists all of the different regions that you can use for AWS services. So just make sure that the one you're in matches the list on the left hand side that you'll see here. Next, let's look at setting up the Cloud9 IDE. So I'll go to Cloud9, which I can see in my list here. I can also search for it in the service dropdown, or I can search for it by typing Cloud9 just there. So there's Cloud9. I just click that so we can open up that service. Now, if you've not opened Cloud9 before, you'll see a screen like this. And the first thing to do is we'll want to create an environment. So we'll scroll down a little bit and start following these instructions that walk you through creating that environment. So in step 1, we go to Services and select Cloud9. That's what we just did. And also we want to make sure that the region is the same. So it's worth repeating that make sure your region is matching that region list. So in step 2, we'll be creating the environment. So click on the Create Environment button, and that opens up the screen where we can create a new Cloud9 instance. In step 3, we're going to enter a name. Now, it suggests the name Theme Park Development. You can give it any name you like, but if you give it that name, it's easy for us to refer back later. You can optionally provide a description too. So I can say, this is my Cloud9 environment for Innovator Island. And then click on Next Step. Now in this step, this is where you can define the type of instance you'll be using for Cloud9. Under the covers, it's an EC2 instance, so we're really just using an environment we're using EC2. And so we can select what size of instance type. If you're using a personal AWS account, I recommend using T2 Micro, since that is often covered in the free tier. So I would leave that option selected there. Now this is step 5 in the instructions here, so what we're going to do is leave all of these defaults as they are. And you'll notice there's an option here, this is the cost saving setting, that will make sure that if you go away from this tab and you close down Cloud9, it puts the EC2 instance under the covers into a suspend mode, so that can help save money. So once you've left all of those options as they are, click on Next Step. Now this is just a review page. You'll see that this is step 6 in the instructions, and that's just confirming all of our settings, our name, our description, the environment type, and so forth. Once you're happy with that, just click on Create Environment. So this now takes just a few minutes, and you'll see that we're waiting on step 7 here, that we're waiting for Cloud9 to catch up and be ready for us. So Cloud9 is a cloud-based IDE. This is an integrated development environment. You may use an IDE on your local machine like VS Code. So being in the cloud has certain advantages to your local IDE. Firstly, Cloud9 contains some serverless development tools that can make it easier for developing serverless applications. Also, you can specify an instance type that might be much larger and more powerful than a local machine with more memory and more CPU types. So in real applications, you can sometimes build a development environment in Cloud9 that's much more powerful than the machine that you might be using in real life. Also, you can use this for code pairing too. You can share your Cloud9 instance with other people so you can see each other's IDE. There's a lot of benefits to using Cloud9. In terms of the workshop, it's just a convenient way for us to have an environment that we're all sharing that is the same. So once Cloud9 has started, as you saw here, it shouldn't take more than a couple of minutes, you'll see that the screen looks very similar to this screenshot. I'm just going to close down these tabs so we've got a new instance we can start with. Also, you don't need to do this, but I'm going to make my font size a little bit bigger so that it's easier for watching this video and seeing what I'm typing in. So I'll just go through and change my font size to 16. And a bit further down, I'll change my font size for looking at files to 16 as well. You don't need to do that, but it just helps when we're sharing this on this video. So I'm scrolling down a little bit further here. So take a look at the 3 different panels that you have in Cloud9. On the left is a file explorer that shows you anything you download to the local instance. It shows you the file structure here. Any files that you open, like the README here, open up in this right hand side. So but there you can edit files and make changes. It's worth noting that when you make changes, they don't automatically save. So you want to ensure that if you see that little icon, that little grey button, that means that you have unsaved changes in the file. So you can save those by pressing Ctrl S or going to File, Save. And once the file has been saved, you won't see that little round icon that we saw before. And then at the bottom here, this is the terminal window. So we can run any type of Linux command here and it'll execute automatically on that remote instance. This isn't running on your machine, remember, this is running remotely on an EC2 instance in the AWS cloud. So let's take a look at running our first command within the Cloud9 instance. So if we've got this command here, we'll highlight this, AWS STS get caller identity. I'll just paste that in. And what you'll see is details of your AWS user role that is currently being run on this instance. And this is important because this is how Cloud9 gets permission to do all the things in the environment. So we want to make sure that this user role is an administrator role, which happens automatically if you're using a personal AWS account. So the output here looks broadly the same as this output you'll see in the instructions on the left. Now this is a good time to make sure that your region is the same as the one in the workshop. And so I've mentioned this a few times, just sometimes it's easy to accidentally flip regions, but this is how you can check within the Cloud9 environment. We can use this script here. So what we'll do is we'll highlight this whole script, copy that to the clipboard, then over here I'll paste the script, and what you should see in the response is the same response here, that you'll see a region name, and that is in a supported AWS region. If you don't get that, pause this video and go back and recreate your Cloud9 instance in one of the supported regions. It's really important at this stage in the workshop before we start deploying any resources. Okay, so we'll move to this next section where we clone the GitHub repository. I'll keep clearing my terminal to make it easier to see what I'm doing. You don't need to do that. So let's start at the very beginning at step 1. So we're going to clone the GitHub repo. So first I'm going to cd into my environment location. You should automatically be there, but we're just doing that to make sure that we're starting in the same place. And then we're going to run this git clone command from this public GitHub repo in AWS samples, and we're going to clone the repo into a directory, theme park backend. So I'll just paste that command there and press enter. After a couple of seconds, you'll see that it's cloned the repo successfully. Then if I open this, you'll see there's a new directory that's been created with a range of different subdirectories and some other files. Don't worry about those too much, we'll be coming back to those in just a moment. So you'll see now that my screen, and hopefully your screen, look like this screenshot shown in the instructions. So scroll down to step 2. So within the Cloud9 file browser on the left, you can see all of those backend files that have been downloaded. And the structure of the workshop is that each module correlates to one subdirectory with a number. So we'll move on to step 3. In this step, we're going to install JQ. And the reason for doing this is some of the commands later output JSON, and it makes it easier to be able to read the format in the terminal. So we'll just paste that command. And so sudo yum install installs packages in this environment, and so we just specify that we want to install JQ, and the Y switch you'll see here means that it doesn't do any confirmations, it just does it without asking us. So this only takes a couple of seconds, and that's now installed JQ. This is just a utility to help us with the workshop. Now the tip here is really helpful. We want to be able to keep a scratch pad open in Cloud9. And the reason for this is there are some values that you'll see throughout the workshop that we want to be able to store temporarily. It's just a convenient way to treat this like a clipboard. So I'm going to open this. I'm going to call this my scratch pad, so you'll know what it is when we come back to it in subsequent videos. You can also use Notepad or any text editor on your machine. Okay, so what have we done in this section here? Well, we've made sure that we have an AWS account to start the workshop, a personal or development AWS account ideally where you have administrator access. We've also made sure that we're running this in one of the supported regions that the workshop works in. And we've created an IDE, a Cloud9 IDE using the default settings. And we've got this open, keeping this open in a tab in a Chrome or Firefox browser. I'm going to be doing this where we have a split screen throughout the entire video series. You don't have to do that. If you have two screens on your computer, that might be more easy to switch between the two of them. So what we're going to do now is we're going to start building the initial application. Let's move on to this next step, deploying the application. So this section explains the back-end and the front-end structure. And so you're going to be deploying the front-end application and then the back-end resources. And then we'll be connecting the two of them and then deploying. And so we'll be achieving all of that in the remainder of this video. To advance, you can click the arrows in the instructions or just click in the directory on the left-hand side. So as I mentioned earlier, this is a progressive web application, a PWA, that's written in Vue.js. This is a single-page application framework. So I've already written the front-end application, so you don't need to write any code. We're just simply going to be deploying what's already been built. And to do this, we're going to be using the AWS Amplify Console. This is a really great way to deploy these kinds of apps because we can connect AWS Amplify Console with a Git repo, and when console detects changes in that repo, it will automatically redeploy the application to a public URL. So it saves a lot of manual steps. It's a really great tool. So the backend is a set of serverless microservices, and so in the backend, in this section, we're going to set up some of those. So we're using a DynamoDB table, and that contains information about all the rides in the theme park, and also the attractions and other things that are going on within the application. Lambda functions are going to be used to perform a table scan on DynamoDB and return all the items. And then we're going to use API Gateway to create an API endpoint, and that enables the front-end application to query that endpoint and fetch a list of the rides. So once you've then built all of the back-end resources that you need, we'll then update the front end with the configuration so it knows which API Gateway endpoint to query, and then that can help display all of the rides in our application. So let's start having a look through all of these different steps. So we want to make sure we've completed the setup guide first. Everything we've talked about in this video up to this point, you want to have completed that before you get this far. Also, if you look at this link here, there's a link to GitHub. I'll open this in a separate tab. This shows the underlying repo where all of this exists. So you'll find all of the same instructions. We've just packaged it in this other website because it's easier to read, but everything also exists here. I'll close this now for now, but you can always look through this to see any of the code later on. Great, so let's continue with the first step. This is the front end. So what you're going to do is you're going to create a code repository in AWS Code Commit. Then we'll download that front-end code into the Cloud9 IDE, and we'll push that code to this repository. And then we'll configure Amplify Console so that any time that there are changes in that repository, it'll then publish the web app. So once we finish this section, we'll then have a published web app that you'll be able to visit on both your PC browser and your mobile device. So this diagram shows how this works. So when you use a desktop client or a mobile client, it will be going to HTML, CSS, and JavaScript assets that have been deployed by Amplify. Now under the covers, all of these assets are actually deployed by CloudFront, and this is a CDN. And the benefit of deploying applications this way is that anywhere your visitors are based geographically, whether in the US or Europe or Australia, they get a fairly similar latency because the CDN is deploying all those assets from edge locations that are located nearer to your visitors. So it helps reduce latency when your users are scattered all over the planet. And that happens automatically when you use Amplify. So let's take a quick look. Now, if you want to look at any of these services in detail, you can follow these links and read more information. You can pause this video at any time and read more of those, but I'm going to get on with deploying the front-end infrastructure in this section. So in step 1, we're going to create the repository. So to start with, we need to, in step 1, go to the management console. So I'll go back, open another tab here. I'm leaving Cloud9 open because we will be going back to that plenty of times. And within the management console, then we want to go to services and select code commit under development tools. So there's code commit. Now once again, make sure that your region in that top right drop-down is the same one you've been using throughout the entire workshop and matches one of the approved regions in the list we saw in setup. In step 2, click Create Repository. And now in step 3, we're going to set the repository name to Theme Park Frontend. So make sure the spelling is identical with those dashes. You don't need to enter a description. And then step 4, I click on Create. And that's it. It's very quick. So you'll notice that that's the screenshot showing how we created a repository before we hit the Create button. And then once you hit Create, you'll see that there is this success message at the top of the screen. Great. So that's all you have to do to create a code commit repository. So step 2, we're going to clone that code base with the front-end code in it. So what we'll do is we'll go back to the Cloud9 tab. So I've kept this open just here. Now if you haven't kept it open and you need to recreate your Cloud9 environment or go back to it, just go to Cloud9 in your service drop down here and open your instance. Everything you did will still be there. If you've kept it open in another tab, just switch back to that tab. Okay, so in this section, so let's look at step 2. So Cloud9 has temporary credentials that are associated with the IAM user that it's using to be able to access your environment. And you can use these credentials with the AWS CLI credential helper. And so if we enable the credential helper with these 2 commands, this makes it easier when you're interacting with code commit. So all you have to do is cut and paste these 2 commands here and paste those into your terminal window. And that's it. You won't see any response. It just sets the credentials. Now in step 3, we're going to use this command to download the front-end code from GitHub into a separate local subdirectory from the backend. So I'll just make a directory using mkdir. You'll see that that now has created this theme park front-end directory. We'll cd into that directory. You'll see that that's now reflected in the terminal window. And then we'll use wget to fetch that code. So it just takes a couple of seconds. Once you've done this, you'll see within there is a zip file that we've just downloaded. Finally, let's unzip that zip file in step 4. So unzipping this code will just expand all of those files. And then as it mentions here, once you've done that, within the Cloud9 file browser, underneath the front-end directory, you'll see that we now have all of these different files and a source directory and a public directory. So that is the front-end application. So once you get to this stage, you'll be in step 5. Now the job is now we want to push this downloaded code to that code commit repository. So let's break apart these different steps to do this. Now we're already in this front-end directory, but we'll just do that to make sure that we are in the same place. I'll clear my window so that you can see what we're doing. Now the AWS region, if I just highlight this entire command here, what this does is it sets the AWS region variable to where you are located, so US East 1 in my case. And then this second command we saw, this git push command, then pushes that code from that directory to code commit. And it uses this region variable to make sure that we're in the same region, basically. So once I've done this, I've now pushed that code that we downloaded up to the code commit repo. So that is step 5 completed. Now these aren't in the instructions, but I'll show you if I go back to code commit and I just refresh this screen. Previously that repo is empty, but now we see theme park frontend contains all the same files that we see in Cloud9 over here. It's matching that same directory there. Now finally, in this section, what we need to do is deploy the site using Amplify Console. So in step 1, we created the repo in code commit. In step 2, we downloaded all the files and synced those with code commit. Now in step 3, we want to make sure that Amplify Console knows about this repo so it can do the deployment for us automatically. So let's go to the step-by-step instructions. We'll go to Amplify Console first. And the way to do that is from the AWS console. We can type in Amplify up here, and I'll open this in a new tab. I'll just close that menu there, switch to this new tab. Now what you'll see here, we'll scroll down to the Deliver section, Get Started, which is underneath the Host Your Web Apps section. So what we'll do when we get to this point is we go to select AWS Code Commit. Now you can use any one of these other code repos. You can use GitHub, Bitbucket, GitLab, and others. You can actually just not use a Git provider if you prefer as well. But in this case, we've got everything synced with code commit, so that's what we're going to be using. So I'll select that and select continue. This is all on step 3 in these instructions here. So you see that this screenshot matches what I'm doing just here. And I'll click continue. So scrolling down to step 4, we can look, this will automatically detect any repos within code commit in this drop down. So when I click the drop down, if you've not used code commit before, you'll just see the one we created earlier. So click on theme park frontend as your repo, then make sure the branch is set to main. It should automatically detect that. And then once you get this far, and again the screenshot here matches this screenshot under step 4, click on next. And then you'll see on the configure build settings page, this is step 5, you can leave these defaults. And we'll scroll down and click on next. Finally, in step 6, this is just a review page confirming the options that we have selected. So just make sure that you see that this is a Vue framework. It detected that automatically. The app name is theme park frontend, and you're using all the default settings basically. So we want to then save and deploy. Now this takes a couple of minutes, so we're going to allow this just to deploy the front end, and we'll just wait for the various steps to follow. So Amplify Console has the capability of enabling you to configure fairly complicated build settings. So for real production applications where you may have elaborate build processes, you can put these into Amplify and it will do those each time it deploys the code it finds in the repo. You can also fairly easily configure custom domains here. So if you have a production application, you won't want to have a development URL, you want to have a production URL, and you can define that here too. And it'll automatically set up SSL certificates for you, so you don't need to manage or maintain any of those. Now I'll open this window just for a second so you can see what is going on with this. Your screen should look very similar. So what this is showing us is, first of all, it's provisioning an environment for it to set up this build. That usually happens fairly quickly. During the build process, what it's doing here is it's discovered this is a Vue.js app, so that uses Node.js, so it'll set up a Node environment and also run the package.json file it finds. So that often means you have to install lots of different modules. So it'll do all of those different things for us automatically, and also run the correct commands in a Vue application to create a dist folder. That's the public folder of servable assets. So it does all of this for us automatically. Now you could do all of this manually as well. It just saves a few steps. If you were doing this manually, you would create a CloudFront distribution and an S3 bucket, and you'd manually do the build and copy everything to that S3 bucket, point the CloudFront distribution at that, and it would be a very similar sort of process. Once the build is complete, you'll see that there's a checkbox there, and the deployment process, that's now deployed. And after it's deployed, Amplify will then go and verify that it's correct. So once you want to make sure that you wait until that final checkbox is there. And once the deployment is ready, this link here, which we're coming back to in a minute, is where the application has been deployed to. But for now, what I'll do is I'll minimize this and go back to the instructions so we can follow along together at each stage. So hopefully at this point, you are at the point where you see the 4 checkboxes and we're ready to move on. If not, just pause the video and wait until it is ready, and I'll be waiting for you. So this, as the instructions said, has published the application at this URL. So let's now open this URL and see what it looks like. I'll click on this. It opens it in a new tab, and you'll see that this is the deployed application. So there's a park map here, and if we scroll around, you can see this is the island with our theme park on it. You can also zoom in or zoom out with those buttons there. So this takes us to step 4 in this section, viewing the deployed application. So you want to make sure you're viewing this within a Chrome or Mozilla browser, just for compatibility reasons. And I'm going to show you how to do steps 1, 2, and 3, but I'll maximize this window to make it clearer. And what we're going to be doing is using the developer tools so that you can see what the application is doing behind the scenes, and also get a view of the application as it would be seen if it were being used on a mobile. So let's just open up this, and we're going to press F12. F12 gives us developer tools in both Chrome and Firefox. I'm using Chrome. They're very similar instructions within Firefox. Click on the console tab just up here, and you can see any console output that's coming from the application. And at the moment we're seeing this in a desktop view, but we can change it to a mobile view by using this device toolbar option just here. So I'm going to click that button, and then I'll select a device that has a reasonably large screen like a Pixel 2 XL, but you can pick any device you prefer. And that then shows you the layout of what you can expect if a mobile user was to use the app. So this is a good way of giving you a simulation of what a mobile user can see. So I'll shrink this down just again. So now you can see we've got the console on the right, the view of the app on the left. And this is being served from that Amplify location. This is a public URL anywhere on the web that anybody could visit. Your URL will look slightly different, so make sure you're using your URL and not mine, because by the time you see this video, this will probably not be there anymore. So that is viewing the deployed application. Let's move on to the next step. The next step is deploying the backend app. So right now you'll see that the front end isn't really doing very much. It's simply showing as a map. It doesn't have any information because it's got no backend to get information from. So we're going to build this backend, and after this we'll be able to see ride information within the park. So this serverless backend uses 3 services as they're described in the instructions here. The DynamoDB table will be there with information about the rides, and the Lambda function will be able to fetch that list of rides from the table, and then API Gateway provides an endpoint, a public URL, that the app will be using to go and fetch those rides. Each time we call this location, it fetches that list of rides for us. So you can look at each one of those services in detail. Feel free to pause this video and follow any of these links to learn more. So let's go to deploying the backend infrastructure. So we talked about Sam very briefly at the beginning, and Sam is the mascot, the squirrel for the park, but it's also the Serverless Application Model. This is an open source framework that makes it easier to deploy serverless infrastructure. So it allows you to specify application resources in code, and then SAM will transform those into CloudFormation and deploy them for you automatically. So again, there's more information if you follow the link here. It'll tell you more about how SAM works. So we're going to complete our first SAM deployment in this section. So let's go through these step-by-step instructions. In step 1, we'll go back to that browser tab where we had Cloud9 running. If you don't have that still running, just from any AWS services window, just search for it in the drop-down and you can navigate to your instance just there. So we've got our existing instance running here, so we'll go to step 2. I'll clear the window. Now the first thing we want to do is make sure that we have an S3 bucket with a unique name that we can use with SAM to do the uploads of deployments. Now for simplicity, we're going to keep this name in an environment variable called S3 deploy bucket, and we're going to use the account ID to give this the unique number. So the way to do this is there's a couple of commands here. We're going to copy and paste this command, and that'll put our account ID, the AWS account ID, into this environment variable. Then the second command will create the S3 deploy bucket variable that gives it this name appended by the account ID. And we'll just echo this out just to ensure that we see this variable with the account ID there. And you should see something very similar to that with a different number, of course. So now in the terminal, we're going to run this command to create the bucket. So we'll say AWS, this is using the AWS CLI and the S3 library to make a bucket. So when I run this command, you'll see you get a response back that it has now made the bucket. And in step 4 now, we're going to change to this directory that contains code that we want to deploy. Once we've done that, you should see, I'll just clear this, you should see now we're in that correct directory. In step 5, we'll use the SAM CLI to deploy the first part of the infrastructure by deploying these commands. So there's 2 steps to this. First is packaging the SAM deployment, and here we can specify the packaged YAML file that contains all the information we need, and also the S3 bucket we're going to use for the deployment, which we already created. So just paste that command in there, and that takes a couple of seconds. And then next we're going to deploy. And we'll run SAM deploy like this. So this just takes a couple of minutes, but what it's going to do now is use the CloudFormation that SAM generates to create a list of AWS resources and deploy those directly to your account. What I'll do is I'll just open this up so you can see this while it's deploying. You should see something very similar. So a SAM template is simply YAML. All it is, we'll be looking at this a little bit later, but it's only YAML that defines what you're going to deploy with configurations for each service. And so you can do all of this in the console manually if you prefer, but by using something like SAM, it helps automate this. And one of the benefits when you're building applications is that's for creating repeatable deployments. So as you make changes to your application and run SAM deploy multiple times, it makes sure the infrastructure you're provisioning is identical each time. So this is the preferred way to manage production applications. We'll come back to this screen in just a second. At the very end, when this is finished, you'll see this says it's been deployed successfully. So we'll wait until we get to that point. So make sure you pause this video until you get to the point where your stack has been deployed successfully, and then we'll continue on from there. All of the backend resources that we have in Innovator Island are all built with SAM templates. So although this is new right now, by the end of this workshop you will have done this a few times and you'll get used to how SAM works with YAML files to create CloudFormation, to create real resources in the cloud. Any one of these things that are being created we can actually see within the AWS console. So for example, the DynamoDB table that was created earlier, if I switch to DynamoDB, I'll just go to DynamoDB here. I'll go to tables. What we'll see here is that this is the table that was created, theme park ride times. And so all of these resources, even though they're appearing in the console here, they do have equivalents in the regular AWS console if you want to go and see them once they've been created. Okay, so that now has been deployed, and you'll see that we've got the same success message that you expect to see just here. So I'll just clear the terminal, and now we're on step 6. So I'll just cd into this directory, and you should be able to see that your directory is now the same. And now we're going to deploy the second part of the infrastructure by running these commands. So we're now in this other application. I'll run sam build. What this does is it goes through the package JSON file and installs all the different npm packages that are used by this part of the application. Next, I run sam package. That takes the YAML file of the template, converts it into CloudFormation, and packages up all of the different assets. And it uploads it as well to our deployment bucket. And then finally, I'll just run sam deploy. And that will now make the deployment just like the first time round. It's going to take those assets and deploy them into the cloud. You'll notice these switches in the deploy command, such as the template file switch we can specify there. Also, it's giving this a stack name. So if I show you, if I can switch to CloudFormation briefly, what you'll see in CloudFormation is a range of all the different stacks that you've created. I'll just search for the ones that are the theme park related. I have several other things in my account here. That's the Cloud9 instance stack. That was the first stack we deployed a few minutes ago. And then this one's currently in progress. But this is the stack theme park backend. And if you look at resources, you'll see all the different resources that are being created in this stack. So that name there, theme park backend, is where it is derived from this switch, this parameter in the deploy command here, stack name theme park backend. Because this stack creates IAM roles, we have to also add this parameter here to give SAM permission to do this. This will just take a couple of minutes to completely deploy. So as this describes here, what this does is it deploys Lambda functions, S3 buckets, and other things that we'll be using later on when we're connecting this up to finish off building the applications. There's quite a few different resources here. Now once this is ready, you'll see again the success message. So if you haven't gone there this far, just pause the video for now, and we'll pick up at exactly the same place in just a moment. So in step 8, let's configure environment variables that we'll be using. So first of all, I'll highlight all of these different commands and paste them all at once. Now what this does is it's simply using the outputs of the stack to find out what the resources were called. Because when you deploy things using SAM or CloudFormation, it appends random strings of characters at the end to make sure they're unique. So we want to make sure we pull those out of the stack, and we're putting those in our environment variables for easy reference later on. So we've got a whole range of different variables here, final bucket, processing bucket, and so forth. And when you'll see a different result for each one of these, but they'll look fairly similar. So you'll see this sort of output here as shown in the instructions. So Sam has now finished deploying the CloudFormation template, so let's move on to populating the DynamoDB table with the ride information. So in step 1, I'm going to cd into this directory, and then we're going to run npm install. In here you'll see that actually, if I just clear it, there is a package.json file, so this is an npm application. So I'll run npm install, and in step 3 I'm going to run this script. This runs an import data script that if we take a quick look at, you will see that it simply just writes results to a DynamoDB table. So that's in this directory, and there's a small node application here that simply uploads data to DynamoDB. So that's what we've just run. Great, so that now you'll see that the screenshot here matches the screenshot I have here. Now let's test this configuration. So in step 1, I'm going to confirm the data is there by running this command. And this command uses the SDK, or uses the CLI to pull the results from that table. So you can see all of these different JSON, just JSON information showing the 27 records in the table. Now we also deployed an API gateway endpoint URL. So let's run that to see how that works. So first I'm going to use CloudFormation to get the endpoint back. So I'll just do this again. I'll clear this so you can see this a bit more clearly. This command returns an endpoint, and this is going to be the endpoint that gives you a list of information about your rides. So if I open this in a new tab, what I can do is just hover over it, click it, and click open. I'm opening this endpoint in a browser tab, and this is the JSON containing a list of all of the rides. This shows that the endpoint is working. So just close that. So that is step 2 completed. And we want to just take a note of this. So if we select this, I can click copy. That copies this URL endpoint to the clipboard. Now, if we go back to Cloud9, we select open and clicked in step 3 already, so you saw how that worked in terms of opening the URL and showing a list of all of the rides. Great, so what we need to do now is take this endpoint and put it into our front-end code so the front-end knows about this endpoint. So I'll click on the next step here. That takes us to updating the front-end and the section on the left. So what we're going to do here is we're going to go to this directory in Cloud9, theme park frontend, which is down here, and go to the source directory, src. I'll open up that. I'm going to locate config.js just here. Now the config contains all of the different elements that are unique to your deployment. And so I've put them all in one file. It's good practice when you're writing front ends to keep all these things in one place. But for the workshop, I've kept all of the configuration in one file called config.js to keep it simple. At the moment, we're in module 1. So this is the section we need here on line 13. So you'll see in step 3, it says that you want to update the init state API and paste in that URL just here. So I'm pasting in that same URL that you see that was output from that command earlier. Now don't forget to save the file, because in Cloud9 you'll see a little ball on the tab when the file is not saved. So let's now save that file. I'm using Control S, and you'll see the little ball thing disappears there. And now let's push that change to code commit. So we'll cd into the front end directory again in step 1. Now you'll see we're back in that front end directory. And now we're going to commit the code, the change that we just made. Now if you want to just confirm that change, you can use git status. But we're going to run git commit and then git push. That pushes those changes that we made to code commit. It's fairly fast because it's only a very small change. Great, so that now has been committed. So what we can do is if we go to Amplify Console, I left this open. If you didn't leave it open, from any tab where you've got an AWS console window, you can search for it here. Just search for Amplify, and you'll see that if you click that, it'll open up that tab. I already left it open, so I'm going to go to that tab just here. Now what you'll notice when you go here, if I just open this up full screen, this has automatically started another build. We didn't tell it to do this directly. What it did is it's listening to that repo in code commit. And because we committed that change to the code, it detected this and automatically started a build. Now this URL is still active with the old version, the very first version of the code that we deployed. So if we go to that URL, you'll see that it's still there, And in a real-life production application, people can continue to visit the old version while the new version is being deployed. So this follows the same steps we saw the first time we did this. It's first provisioning an environment. It's running a build, which means going through the package.json file of this Vue.js application and installing all of the packages and running the build scripts. Once that's been completed, it then will deploy the new version. Now, the great thing about Amplify Console when it does this is it actually creates an entirely separate version when it's doing the deployment. So it makes sure that deployment is successful before pointing your URL, your production URL, to that new version. So if there are any problems, it makes sure that your old version stays live on the internet so your customers can continue to use the application. So this is why I think it's a much better way to deploy applications than manually copying to S3 buckets, because that can be very error prone. Now, once this process is finished, only takes a couple of minutes, you'll see that you've got 4 check marks and the URL doesn't change. That's the same. I'll just minimize this again so we make sure we're following the same instructions. So what we want to do, we're in Amplify Console here. And on step 5, we're going to open that URL again to be able to make sure that the new application is there. Now I already have this open, but I'm pointing to the old one. So I can now F5 to load the new version of the application. Now what you'll see is we've now got rides that have appeared in the park. And if I click any of them, you'll see descriptions of those rides. So this is the new element. What's happening is that this front end is now calling that API endpoint to fetch a list of those rides from that DynamoDB table. And you'll see that's the console reflects that it's making that invocation, and you're getting a 200 back, and that's how the rides are now appearing in the map. If you're not seeing this, make sure that your browser cache isn't looking at the old version of the app. You can press Control F5. There's some information here in this window to help you make sure you're fetching the very latest of your deployed application. So now you can see rides and attractions within the theme park map. So that's what we've managed to achieve by connecting the front end to the back end. So let's do a quick review of what we've done here. Well, we created a code repository in Cloud9, and then we configured Amplify Console to publish the web app in this repository. And so that gives you this public URL endpoint for your application. We deployed backend infrastructure of the theme park and the application. And then we populated that DynamoDB table containing the ride and attraction information for the park. We tested this deployment by using the CLI to scan a DynamoDB table, and that gave us a list of JSON rides coming back in the terminal. And we tested that API gateway endpoint. And then we updated the front end in the config.js file with that new API endpoint and saw the results. And then we pushed all of those code changes to code commit, and then we saw how Amplify Console automatically detected that change and published a new public front end for us automatically without us having to do anything beyond the git push. So in the next section, we're going to be looking at how we add real-time wait times to these rides. So thanks very much for joining me in this video, and I'll see you in part 2, where we'll be picking up the real-time changes for these rides. And don't close down any of your tabs or any of your Cloud9 instances. We can pick up straight up where we left off.